Hi everyone, this is Aptap Limboo, a student of third sem, and my topic for today is Frank-Hurst experiment. So I would like to give you a brief history about Frank-Hurst experiment. It was studied in 1914 by James Frank and Gustav Hurst and presented to the German Physical Society. It was first electrical measurement to show the quantum nature of atoms. The Frank-Hurst experiment consists of a vacuum tube designed to study the energetic electrons that flew through the thin vapor of mercury atoms. And it was discovered that only a specific amount of an atom's kinetic energy would lose as the electrons collide with the mercury atom. Now I would like to give you a brief introduction about this experiment. The Frank-Hurst experiment was the first electrical measurement to clearly show the quantum nature of atom and thus transformed our understanding to the world. And it was presented on April 24, 1419 to the German Physical Society in the paper by James Frank and Gustav Hurst. Frank and Hurst had designed a vacuum tube for studying energetic electron that flew through a thin vapor of mercury atoms. They discovered that when an electron collided with a mercury atom, it would lose only a specific quantity of its kinetic energy before flying away. So this energy loss corresponds to decelerating the electron from a speed of about 1.3 million meters per second to zero. A faster electron does not decelerate completely after a collision but lose precisely the same amount of its kinetic energy before flying away. This energy loss corresponds to decelerating the electron from a speed of about 1.3 million meters per second to zero. A faster electron does not decelerate completely after a collision but lose precisely the same amount of its kinetic energy. Slower electron merely bounce off mercury atoms without losing any significant speed or kinetic energy. So here is an image of the experimental setup for Frankel's experiment. So in this image you can see the photograph of vacuum tube used for the Frankel's experiment in instructional laboratories. So there is a droplet of mercury inside the tube. Although it is not visible in the photograph, the cathode itself is hot and glows orange as it emits electron which passes through the metal mesh grid G and are collected as an electric current by the anode A. So these are the diagram of Frank-Hurst experiment. So in the left hand side we can see the diagram of Frank-Hurst experimental setup, and in the right hand side we can see the graphical representation of Frank-Hurst data. So now we are going to discuss the aim of the experiment, which is to demonstrate the concept of quantization of the energy levels according to the Bohr's model of an atom. So here are the list of the material required for this experiment. Number 1, oven. Number 2, a control unit for power supply. Number 3, a DC amplifier. Number 4, mercury filled Frank-Hurst tube. Number 5, a neon filled Frank-Hurst tube. So now we are going to discuss the theory of the experiment. The original experiment used a heated vacuum tube of temperature 115 degrees Celsius with a drop of mercury of vapor pressure 100 Pascal, 3 electrodes, a electron emitting hot cathode, a metal mesh grid, and an anode are attached to the tube. To draw the emitted electrons, the grid voltage is made positive with respect to the cathode. So the electric current measured in an experiment results from the movement of electrons from the grid to the anode. The electric potential at the anode is slightly more negative than the grid, so the electrons have the kinetic energy as the same as in the grid. And the Frank-Hurst experiment was explained in terms of elastic and inelastic collision between the electrons and the mercury atoms. So the inelastic collision is a collision in which kinetic energy is not conserved due to the action of internal friction, and an elastic collision is an encounter between two bodies in which the total kinetic energy of the two bodies remains the same. So in the image we can see the graph which shows the dependence of electric current flowing out of the anode and the electric potential between the grid and the cathode. So following are the observation of the graph. With the steady increase in the potential difference, the current increased steadily through the tube. The current dropped almost to zero at 4.9 volts. Again, there is an increase in the current as same voltage increases to 9.8 volts. Again, a similar drop is observed at 9.8 volts. So, the energy absorption from electron collisions in the case of neon gas is seen, where the accelerated electron excites the electron in neon to upper state. They de-excite in such a way as to produce a visible glow in a gas region in which the excitation is taking place. There are about 10 peak electron level in the range of 18.3 to 19.5 electron volt, and they de-excite by dropping to lower states at 16.57 and 16.79 electron volt. This energy difference keeps the light in the visible range. So now we are going to discuss the result of this experiment, which proves that every atom has stationary orbits. Electron can stay in that orbit without emitting energy, as they cannot emit in the form of quantum. So this feature enabled Niels Bohr to modify Ernest Rutherford's model of atom. So with this, I'd like to conclude my presentation. Thank you.